Gentlemen, what's going on? Well, let's just go through what we're gonna try to explain and what we're doing. So, what we're kind of doing here is we're building a box for a 6KD6. This box is going to be kind of like a test rig where I can put different tubes into it and basically just figure out what the circuits are and what they aren't. So what I'm going to briefly go over is just basically, to do half this stuff, there is no and there's no parts list, man. You gotta work with all the different parts that you're getting, that you can find. You can't just go on down to the air variable store and pick up the exact variables that you'd like to have. If you can find a couple, hey, more power to you. Anywho, you need stuff like the data sheets and stuff like that, what your tube pins layouts are or whatnot, and you can Google search and get all these things. Most of you cats already know this stuff, so I'm just going through some basic stuff for anybody that knows a little tiny bit less than me, because I'm not the go-to guy on all this stuff, but we're gonna work through all this together. We got pin out layouts and stuff like that on how we're gonna run this box. This box can be ran a little bit differently than it typically would be ran, and this is the entire circuit that how this one's gonna be ran. And like I said, this is just the pin layout. Let's see. What we're going to be looking at here today is this right here. Make sure that's in the screen. Just like that. All right. So what we're going to be looking at is we're going to be looking at a part of this circuit here, and what we're going to do is show how you can test this circuit and test for your voltages a little bit safer and at less numbers. So what I got here is this little transformer here. I'll turn it over so you can read it. We'll see if we can zoom in a little bit on it. Zoom in. Nope, that's not zoomed in. That's zoomed out. Maybe that is good. There we go. We'll try right like that. So what this is this little transformer runs on 240 or 210. You can change the little posts around to make it hooked up differently. It shows you right there on the little deal. And this is a 24 volt transformer. With this transformer though, we're actually got it wired up right now for 240, and we're not going to run it at 240. What we're going to do is we're going to run it on the 240 side, but we're going to run it off of the 120 110, and that is going to give us 12 volts. It's going to give us 12 volts out right here. And the reason that we're going to go with the 12 volts out is because we can run this transformer to power the transformer in our box, and that's only going to be 1/10. It's going to be all 1/10 the power. So everything that we're going to see, multiply it by 10, that's what it should be. And it's safer for the components and safer for your dick beaters, so you don't blow your finger off. So what we're going to do here is we're going to take this transformer right here, and we're going to end up hooking this guy up to this box. And we'll run it through some tests. So this box here was an ICO model 377. It's just basically been gutted, a couple things swapped around, drilled some switches out, put some other variables in it, kiped some of the sockets out of it, and we're going to do some testing here through the transformer to give us some numbers. So what we're going to do is we'll show you this over here. So what we've got is we've got some variables in here. We're not going to be doing nothing with those. These are just ones that I put in here, but basically we're going to test the transformer, and we're going to be testing it through our bridge rectifier circuit. So what this is, let's see if you can see that. Our bridge rectifier has been put together inside of a tube socket. So what we've done is break the glass out of there, and we're just using it so we can plug it in and be able to unplug it and change what the circuit is. We could do the circuit differently and then not have to do the wires on the bottom, and we can put a different one in here to do it differently if it wanted to be grounded grid or whatever. So it's just basically our bridge rectifier is actually down inside here. So we'll put that back inside there, how it goes in there. Whoop. And within our circuit, that little bridge rectifier, it's all right here. And on the bottom of our box here, we've got the high voltage leads right here, and we've got our center tap right here, and then we've got our lower voltage right here. That's for our bias circuit right here. So what we're going to do is, like I said, we're going to let's see if we got all that in here. Maybe we should back this out some like that. There we go. Now, I don't know if you saw any of that. Anyways, we'll go like this so you can see all that stuff. The bridge rectifier is over here. These are the caps that we're going to be used later, but we're not going to worry about that right now. What we're going to do is we're going to test this transformer and see what it does. So what we'll do is we'll grab a screwdriver here. This transformer is unplugged. We're going to go like this. We're going to hook these up. And this way we can power the circuit, like I said, at 1/10. This isn't me. This is all somebody else. Somebody else tells me how to do this, and then I think it's cool, and I think it's good information for other people that would like to work on or build boxes, or at least know how it works or how it could technically work. So what we'll do is we'll get the voltmeters and stuff out, and we'll get some jumper leads, because that'll make it a little bit easier to test everything out. So let's see here. We're gonna have to figure out how to edit videos, because I should have had more of this shit ready, but I didn't. We ain't got none of that fancy BBI editing going on around here. Ain't none of that fancy editing there, 410. So what you need to get yourself a good a voltmeter here. This is an older Fluke voltmeter. This is a 8060 alpha. This is a pretty good meter. So it's old, but it's a really good meter. Let's see. Shit, where are my other leads at? This is what happens when you're not prepared. Okay. Here's these leads right here. So what we'll do is we'll start off with this. We're gonna leave this box turned off, and then I'll show you what the voltages and stuff that we're actually getting as we go along here. So what we'll do is we're going to turn this guy on, and we are on. This thing's got all kinds of these little weird push button selectors and stuff like that. So what we're going to do is we're going to set this up for AC volts, AC, and on volts. So that one's in for volts, that one's in for AC, and then we'll click on this for 1000 volt DC, 750 volt AC is where we're going to be at. And what we're going to do is we're going to plug the transformer in and see if it burns down. Nope, not yet. So we get on here and we check here and here, and we're seeing about half that voltage. You know, the line voltage might be a little bit more, might be a little bit less, but we've got 12.8 volts. So that's pretty close to 12 volts. Close enough for the girls I go with. And this line, we're just using this generic little extension cord just as a jumper, just to get from there to there, down over to here. That's powering up to that. And then now what we're going to do is we're going to turn it on. So, okay, no sparks yet. So now that we've got it on, we're going to test what the AC voltages are. And then what we're going to do is we're going to put these little guys on here and these guys on here, and we're going to turn that off, and we're going to check from one lead. Maybe we'll take these off, might be easier to get on like this. What we'll do is we'll get from one lead to the other lead. So these two right here are your high voltage coming off the transformer. And so if we touch this and touch this, it's going to be 65.6. So that's 650. Times that by 10. That's what you got. And then if we come off and we go over here to the center tap, that's going to give us half of it. So we'll put the little clippy on here. We'll test that right here. Clip it on there to make it a little better connection. We touch on this one, 4.3. Go over there, 3 point something. Basically half of what we had over there. So when we center tap it off of here and here, that's half of what our high voltage is, because it's a center tap. If we grab both sides of it, like we did like this, it's going to give us the full voltage. Like that. A lot more. These two right here, these ones are your bias supply. We'll be using it for the bias supply, but what it is just another lead that's lower voltage. And when we go on that one right there, yeah, it's 5.4. So could be a little closer to 6 point whatever. There you go. Maybe it's supposed to be times 10, so it should be. Maybe it's not making good connection. There we go. 3. See that? Yeah, 4. So that's half the voltage right there. Just times it by 10. It probably wasn't making a good connection. So, with that being said, right now we know what our voltages are supposed to be on the AC side. So what we'll do now is we'll check our bridge rectifier. So we'll turn that off and we will unplug it, safety third, and we check that, nothing there, so we're doing good. What we're going to do here is we're going to run jumpers off of the bridge rectifier. We're going to do this because it's, let's see if you can see it there. It's really hard to get down inside there, right down inside there to get the clamps and everything on there. So these are just going to be extensions of what that is. Let's see. So 1/10 of the stuff. Yeah, so that was our high voltage. The center tap was half of the voltage. Half of the voltage of the full secondary. So we got all that. Then our filament current, that's around 0.6. That's what that should have been, was right around 0.6. That's sometimes if you don't have a good connection on there, it's gonna read all weird. So now we're gonna unplug everything. And we're gonna put the jumper leads on the bridge rectifier. So right here with the one with the silver lead in the middle, that should be that one right there. We're gonna put our red lead on this one, and then we're gonna put our black lead on the other one, and then we're gonna roll it back on its side just so you guys can see what we're doing right here. So make sure this is all within the screen there. Then we're going to, oops, put that on volts. We're gonna put our meter right here. Hopefully you can see that. Yeah, I think you can read that. And then we're gonna change our voltmeter to DC. So we're going to bring that one out. Now we're on DC volts. And we're going to put these little guys on here because they work pretty good on clamping all this. We're going to clamp the red on the red and the black on the black. And we're going to see what our rectified voltage is. So we're going to take this guy right here, plug this back in, switches off, contact. And we're going to see 55.3. You can see that's jumping around a little bit. The interesting thing about this is that this is actually not what the voltage is. The problem is there's a ripple. There's a ripple in the voltage. And with the ripple in the voltage, it's not giving you what the whole voltage actually is. It's pulsating so fast that you can't see. So it's only picking up like what an average number is of it, of the highs and the lows. So it's not, and it don't have nowhere to go. So what we have to do is see what the actual voltage is of that. So we need to put a there's no capacitance in that. There's no capacitance in this circuit right now, so it's not going to there's not going to be it's not going to read all the actual voltage. So what we're going to do is we're going to turn that off, and what we're going to do is we're going to install a cap right here, this capacitor. So this is just a 330 volt 150 microfarad cap. And what we're going to do is we're going to take this guy and we're going to put it right in here. So we're going to go trying to remember how I did this before. I've done this like 3 or 4 times now, and I'm just trying to make sure I got enough room for everything. Well, maybe we'll flip this around this way. There we go. Then we'll make sure you guys can still see the meter, I think. There we go. That should be good. Now we'll go like this. We're going to put this on like this, and this on like this, this on like this, and that on like that. And contact. Now see how the voltage is way higher now. I think we're at 56 something before, and now it's at 86 point something, and it's going to raise a little bit. It's filling this. cap up, but it's bumping itself up. But this now it's being filtered. It's being filtered through the cap, and so you're going to not have that DC pulse going on now. It's actually filtering it, and it's keeping it under control. You've got not an erratic rate of AC to DC oscillation with the voltage. Now it's just sitting higher. So if you don't have caps, it's not, you're not going to get the right reading. Or if you're taking your reading at the wrong spot before the caps, you're not even going to get the right reading. You got to, you know, be in the right spot to test it at. So you can see it's leveled off now. I think it gets up to like 90 or something, 800 and something. It almost gets to 900, 90 on this, because remember, everything's times 10, so we're only putting 12 volt AC into this circuit. Now this is another interesting thing. You shut it off and the voltage just stays there. See, there's no bleed down in the circuit right now. So now it takes forever to go way down. It takes a really long time to go down. But if you put a resistor in there, well, then it'll go much faster. So what we're going to do is we're going to jump this little resistor in there for right now. Try to. Might be able to get this in there. By the time I get done fucking around, it'll probably be already low enough I can just grab the fucker. But we'll see. Yeah. That's how that's fucking working out. So you can see how I go really slow. And then when I put this on there, it goes way faster. See, it's creating resistance between it, and it's bleeding it down from the one side to the other side. And once we get it down below 30, I can probably touch it. We'll go a little further. I've grown kind of accustomed to these fingers. So now, that off, pull this off, we'll pull this off and that off, and this off and that off, and what we'll do is we'll lay a little resistor back inside there, like so. So we take this guy like this, and then we put this one on like so. Oops. Then this one on like so. And then we'll go like this and like that. We'll jump these again. You can see there was still some in there, but I didn't get shot. So now we got everything on there. See, we're right back up where we were before. And now the bleed down will happen way faster. See, way faster. The now with that all shown, we'll see what half of that voltage of the numbers are. I'm not really the best at explaining all this. I kind of know what I'm talking about. I know just enough to get myself in fucking trouble. That's kind of where we're at here. So what we're going to do now is we're going to unhook this red wire off the bridge rectifier, which is the center one on the silver band. and we're going to attach it to the center tap. So this one here is the center tap. We're going to attach it right to that. And then we're going to, oh, we shouldn't have taken those off. We'll put these back on like so. This over here. And now this should read half that voltage when we turn it back on. So that was, we were almost at 90 is where we were at before. We were almost at 90. Now we turn it on. 45, 44.3. That's almost 45. That's half a 90. And then remember, all these numbers are 1/10. So if you come off of that on the bridge rectifier and come off this center tap, that would be 440. 444 volts. We're only at 44 volts right now, but that's because we're only running 1/10 of the stuff. No. Yeah, we're just moving it over one spot. So yeah, 40 times 10 is 400. There you go. And then, so this is going to show you that you, of all the different things that you need to have when you're figuring out these parts of the circuit and stuff. And this is also going to help you with figuring out how much voltages you have or you don't have without having to fire it up with complete voltages.